Check. Very warm good morning to all of you. Welcome to the 38th lecture of environmental engineering subject. So we have come to unit 4 of environmental engineering. So in this unit 4, we have totally topics related to the secondary treatment process in wastewater management. So in this unit 4, we'll discuss totally about wastewater management regarding the secondary treatment process. Okay, so in the earlier classes, we have discussed about the primary treatment process, right? So we discussed about the primary treatment process. So in this session, we will start about the secondary treatment process. What are the various secondary treatment processes you are having so that the water can be treated well? Okay. Now see the topics what to be covered in this unit 4. Coming to the introduction of the secondary treatment process, here you are having the aerobic and anaerobic treatment process, the introduction of the aerobic and anaerobic treatment process and their comparison between them. So where we are using anaerobic process, where we are using anaerobic process. These things we are having in this class. Okay. And the second point is suspended growth process. Suspended growth process. So in the suspended growth process, what are the various types of suspended growth process we are having? So we will discuss these things in this second topic. So what are the various things you are having? The various things you are having for the suspended growth process of this bacteria or microorganisms are activated sludge process, designs of the activated sludge process, and operational problems and operational problems. Second, next, coming in that activated sludge process, we have some of the modifications related to that. That is modifications of activated sludge process. So in this modifications of activated sludge process, so what are the various things you are having means the oxidation ponds, aerated lagoons, oxidation ponds and aerated lagoons. So this aerated lagoons means it is a place where the water can be created by some of the microorganisms. Okay, that I will show you in the picture form. Next one is attached growth process. Attached growth process. In this attached growth process, the trickling filters, mechanism of impurities removal, classification of the attached growth process, the design of the attached growth process, the operational and maintenance problem. So this we'll discuss in the third topic of unit 4. Next one you are having RBCs and fluidized bed reactors. RBC and fluidized bed reactors. So these are the various treatment processes we are giving for the water to be treated in any industry, or it may be domestic water, or it may be a storm water. So generally we go for this industrial water treatment process. Okay, so we will discuss all these topics in detail in unit 4, right? So here you are having 90% of theory and 10% of problems, right? In this unit 4 we are having 90% of theory and 10% of problems. Next, so if you see the figure, how the water is going from your domestic to the sanitation, how the water is going from your house to the main sewer pipeline. See the 1, 2, 3. These are the things coming from your house. So the 4 is the one where the rainwater is falling on the ground. Thereby the rainwater is flowing under this or under this manholes, under this places. So here the water is, see the blue color coming from the various pipes. Here the water is flowing, here the rainwater is dropping here, and both are collectively forming and going in this. This is a catch basin where the rainwater is falling here also. and again this one are going to this catch basin. Next, this is going to the main sewer pipe. Here also the water, whatever the rainwater falling, so in this catch basins are going and falling in this sewer main pipe. So this, at the same time, the street inlet. So whenever you are having the street inlets 5, right? This is a 6, this is a 7, the 8th one is a manhole, 9th one is a private sewer pipes, 10th one is public sewer system, 11th one is public private boundary. So some things here also the sewage can be divided into two types. One is a public sewage system, other one is a private sewage system. Okay, so this figure depicts how the domestic wastewater is moving from house to the sewerage system, right? So this, once the water is coming here in the sewer system, this should be treated. Now, how many forms this is being treated? One is a primary form, secondary form, and advanced forms. Depends upon the toxicity or depends upon the pollution of the water. Next, every unit, every unit, that is the second, third, fourth, fifth, or sixth unit, keep in mind how the water is coming to the industrial water, to the industries, to the sanitation, etc. So the sources of water of two types, that is surface water and groundwater. Keep this slide in every unit, keep this in mind. Sources of water. Water అనేది మనకి ఎక్కడి నుంచి వస్తుంది? వేరియస్ ఇండస్ట్రీస్కి, అగ్రికల్చర్కి, domestic applications ki water అనేది ఎక్కడి నుంచి వస్తుంది? So we are having two cases of water. One is the surface water, other one is a groundwater. Coming to the surface water, we are having the lakes, we are having the ponds, we are having the streams, we are having the rivers, we are having the storage reservoir. Coming to the groundwater, we are having the open wells, we are having tube wells, we are having the artisan wells, we are having the springs, we are having the infiltration process. So these are the major sources of water. Under that, we are having the various types. Okay, next. So in this fourth unit, we will discuss mainly about the secondary treatment process. So in the till unit 3, we have discussed about pre-treatment or preliminary treatment process and primary treatment process. Okay, so up to here we have discussed in the unit 3. Up to here we have discussed in the unit 3. Okay, now this one is a up to here. This one is a unit 4. This is a unit 4. This one is a unit 5. Okay, so whenever the industry is polluted with the wastewater, whenever the industry is sending wastewater for the treatment plant, this process or keep on going on continuously. So once the water is being treated under tertiary or advanced treatment process, the effluent water is passed to the receiving body, that is maybe open atmosphere, that is the sea, oceans, rivers, or canals, right? So in the preliminary treatment, removes material that can be cause operational problems, equalization basis or optional. So the preliminary treatment has been completed. The second one, in the primary treatment process, we remove 60% of solids and 35% of biochemical oxygen demand. That is in the primary treatment. Everything is not be removed. Only some amount of suspended material, some amount of sludge material, some amount of scum materials can be removed in this primary treatment. In the secondary treatment process, where we have to discuss, it removes 85% of BOD and solids. Here 60% I think. Here 35% of BOD means here 85% of BOD and the other solids can be removed in this process. Okay, in this process. Next. In the third case, the advanced treatment process, 95% of BODs and solids are removed. That is nitrates and phosphorus. So we are here. We will discuss this topic in detail. Secondary treatment process. Okay. Yes. So we will discuss the biological treatment and secondary settling. What are the biological treatment process and how the secondary settling process can be going on. uh, see the figure here. From this figure, as already discussed in the unit 3, so we have computed this preliminary treatment process, primary treatment process up to here, right? So the water is going in this horizontal way, the solid sludge is coming in the vertical way, and again is depositing in this tank, separate tank. Finally, it is nothing but sludge management system. So it is unit 6, it is unit, yeah, it is unit 3. This one is also unit 3. So here, see this dotted portions. The dotted portions are good. This is unit 4. This one is a unit 5. It has been divided like this. So now we are in this position. Okay. Here, whatever the water is treated in the primary treatment process, the water is coming through the pipeline in the secondary treatment process for biological oxygen demand, right? And the solid content is coming to the down pipes and in the form of sludge that is segregating in the separate compartment. Okay. In the secondary treatment process, we do mainly with this aerobic and anaerobic decomposition process. Okay, that's happening in the secondary treatment process. Okay, next. So this is a pictorial form of the situation. Next. So the primary treatment process in detail we have completed the raw waste sewage, screens, bars, communicators, grid chambers, all the things, primary clarifier. So from here we will start doing unit 2. So this not separately done. Whatever the entire setup you are showing in the figure or maybe in the real industrial area, separately it will not be there. So the treatment just the changes. So up to here the primary secondary treatment just convert, that's all. But the pipelines will be same. Pipeline collections will be same. So in the secondary treatment process, we are having the separate setup where the water is further treated and the sludge is coming in the download position and collecting in the separate tank. Okay, so here we are doing majorly the biological treatment process. Okay, so this will discuss this treatment process we will discuss now. So we are having separate activity research process. We are having the discharge to surface water third treatment process. So we are adding some sort of disinfectant so that the water will not be get polluted or poisoned. Okay, next. Then what is the meaning of secondary treatment? Why we have to go for secondary treatment though the primary treatment process is completed? Enduku the secondary treatment process is a biological treatment process that removes dissolved oxygen matter from the wastewater. Keep this in mind. Simply, if you want to understand, so it is nothing but secondary treatment process is a biological treatment process. Biological treatment process that removes what? That removes dissolved organic matter. వాటర్లో వేస్ట్ వాటర్లో ఏదైతే ఆర్గానిక్ మ్యాటర్ ఉందో that it will remove by biological treatment process. Okay, it removes biological treatment process that removes what? That removes dissolved oxygen matter from the wastewater. Wastewater లో ఉన్న dissolved oxygen matter ని biological treatment ద్వారా it will remove. That is the meaning of the secondary treatment process. Next point. Sewage microorganisms are cultivated and added to the wastewater. So generally in the sewage, microorganisms are added. Microorganisms will be produced in the sewage water. Why? Because it is a polluted water. Maybe in the industries, maybe in the domestic purpose. So here the microorganisms are cultivated and added to the wastewater. అప్పుడు ఏం చేయాలి మనం? These microorganisms should be removed. So the microorganisms use organic matter from sewage. The microorganisms use organic matter from sewage as their food supply. అర్థమైందా? What happens now? So whenever the sewage water produces microorganisms, okay, the microorganisms బతకడానికి, so in order to get their food, in order to live in the water for the food supply, they will depend upon the organic matter. They will depend on organic matter. For example, from our vegetable waste, or if you see in a big hotels, whatever the kitchen waste is coming, so it is nothing but the organic matter. It slowly decomposes. How it decomposes is because of this microorganisms. Why these microorganisms are decomposing? Because for food supply. Microorganisms బతకడానికి it requires food కాబట్టి it depends on this organic matter. This process leads to decomposition or biodegradation of organic waste. So ఈ ప్రాసెస్ ని ఏం చెప్తున్నాం ఫైనల్ గా మనం decomposition or biodegradation of organic waste అని చెప్తున్నాం. Right? Understood? Very simple concept. Secondary treatment process means it is a biological treatment process that removes or dissolved or organic matter from the wastewater. Organic matter ఏదైతే sewage water dissolve అయ్యి ఉన్నదో ఆ వాటర్ని ఆర్గానిక్ మ్యాటర్ని in order to remove it we use secondary treatment process. How you will remove? So in this sewage water microorganisms are cultivated and added to the wastewater. Microorganisms అనేది we are added to the wastewater. Then these microorganisms, in order to survive, in order to get their food, what they will do, they will depend on this organic matter. This process leads to what? Kullipodam, decomposition of the organic waste. This process is known as decomposition or biodegradation of the organic waste. Next. The basic approach is to use aerobic biological degradation. What is the basic approach here? The basic approach is to use aerobic. Aerobic means in presence of oxygen. The basic approach is to use aerobic biological degradation process. So what is this reaction here? Organic carbon plus oxygen. ఈ రెండు కలిపితే so we are getting carbon dioxide plus new cells formation. Okay, so organic carbon plus oxygen gives rise to through the microorganisms. We are getting carbon dioxide, we are getting new cells. So that is the meaning of aerobic biological degradation process in the presence of oxygen. In the presence of oxygen, that is the meaning of secondary treatment. So keep this slide or keep this topic in your mind till you go to 4.2. Very simple and straightforward definition about this secondary treatment process. Okay. Next, what are the objective? Right? What is the motto? The objective is to allow biochemical oxygen demand to be accepted in the treatment plant rather than in the stream. So stream low biological BOD process chese badalu, whenever this BOD process is done in the treatment plant, water treatment plant, this secondary treatment process can be achieved. Then how it is accomplished? Ela chestunam dinni, create a very rich environment for the growth of diverse microbial community. So what is the concept here in the secondary treatment process? We have to create a rich environment for the growth. ఇప్పుడు మనం చేపల చెరువులో వేసి ఎలా చేప పిల్లల్ని గుడ్లను వేసి ఎలా చేపల్ని how you will grow in the same way allow the microorganisms to grow in a very rich environment. ఎంత microorganisms అంటుంటే అంత అక్కడ decomposition జరిగి the organic matter will be dissolved or it will be removed in the secondary treatment process. Create a very rich environment for the growth of diverse microbial community. So జాతులు microbial జాతులను బాగా పెంచాలన్నమాట. So see here the various types of microbial structures. So this is one family, this is one family, okay, this is one family, this is one family, okay, this is one family. So like this we are having various types of families in this microbial community. So these things we have to keep on multiplying in the water. Which water? Sewage water. Why? In order to remove the organic matter present in the sewage. For this reason we have to allow the BOD analysis in the treatment plant rather than a stream. Stream lo unte em jarugutundi, sarigga process jaragadu. Why? Because the stream is always flowing, so there is no development in this process, whereas in the treatment plant we are having a proper development. Okay. Yep. Then what are the basic ingredients we are using for this treatment plant? Okay, now we use high density microorganisms. High density microorganisms means keep organisms in the system. So we are using very high density of microorganisms in this BOD analysis. Next, good contact between organisms and waste. So good contact between organisms and waste. Next, provide high levels of oxygen means aeration. Okay, aerobic అన్నప్పుడు ఆక్సిజన్ ఉంటుంది, anaerobic అన్నప్పుడు ఆక్సిజన్ ఉండదు. Keep that in your mind. Aerobic means keep oxygen is available. Anaerobic means no oxygen is available. So it provides very high levels of oxygen means aeration process. Favorable temperature. So మనకి high temperature ఉండకూడదు, very low temperature ఉండకూడదు. The temperature should be in normal room temperature. Favorable temperatures for the growth of organisms. The water quality should be at good quality level, that the pH scale, and the good nutrients. Design and operation. Design and operation of this water things. That is the physical water process. Next, no toxic chemicals should be present. Why? Because whenever the toxic chemicals are present, what happens? The microorganisms will die. So that's why in industries also we have to remove the toxic or some other materials in the primary treatment process and send to the secondary treatment process. There can be properly control of this sewage water. So no toxic chemicals should be present in this concept. These are the basic ingredients should be keep in mind before doing this body treatment. Next, then what is the main composition of the water? Right? What is the main composition of wastewater? Wastewater, what is the main composition you are having? So this is also a good question. The typical composition of wastewater based upon the strength. And together based upon the strength and based upon the value and based upon the quality, the typical composition of wastewater is based upon the strength. The important characteristics measured in the wastewater are the important characteristics present in the wastewater are first one is the important characteristics of the wastewater includes biochemical oxygen demand, that is BOD, biochemical oxygen demand. And Tundali 100 to 300 mg per liter as oxygen. Oxygen paranga, it should have in between 100 to 300 milligrams per liter. Okay, so that is BOD. Next, second one, suspended solids. Suspended solids, that is SS. 100 నుంచి 350 mg per liter ఉండాలి. How much? So in between this range. Third one, the settlable solids. In the settlable solids, we require 5 to 20% ml per liter solids. mg per 5 to mg per liter. Next, total cadal nitrogen, that is TKN antam. Abbreviation is total cadal nitrogen, that is 20 to 80 mg per liter. Next, total phosphorus and the total phosphorus should be 5 to 20 mg per liter as phosphorus. So like this, the wastewater composition we have to add like this in the wastewater or sewage water. So this will be as a question also. Okay, keep this in mind. So this will be as a question also. So slides and I will prepare unit wise slides and I'll give to you so that in your exam you can read easily. Okay, next. A typical solids analysis of wastewater. So when you have to read the analysis of the wastewater, so thereby of the total wastewater, the total solids, 50% is dissolved, 50% is suspended. Of the suspended solids, 50% will be settleable. Okay, so 50% dissolved, 50% suspended, 50% will settle. Okay, next, the industrial activity changes the composition of wastewater. The industrial activity changes the composition of wastewater, often introducing toxic substances. So ఎంత మనము we have to reduce the toxic waste, but definitely some sort of toxic waste will be added in this industrial wastewater whenever you are going for the manufacturing process. So in the earlier semester you have learned about the various factories, how they are manufacturing. For example, if we take the tanneries industries, or if we take the garments industries, or if you take the textiles, or if you take any paper and pulp, definitely the toxic substances are involved in the wastewater, such as chromium, cadmium from the plating operations. If you go for any plating operations, structural steel or surface plate operations factory, so the toxic substances like chromium, cadmium. So So if you take any paper and pulp also, you require some sort of chemicals. If you are going with the textiles also, you are having some sort of chemicals. Thereby, every industrial activity changes whatever the composition. So here, see the composition. We used this composition for the wastewater, but in every industrial activity, the composition అనేది definitely will change because of introduction of the toxic substances. Example వచ్చేసి plating industries లో chromium and cadmium. Next, the secondary treatment removes 85% of BOD. So what is the concept here? The secondary treatment process removes 85% of BOD and suspended solids and most pathogens, but can leave high nitrogen and phosphorus concentrations. Okay, but can leave high nitrogen and phosphorus concentrations. Secondary treatment removes how much? 85% of the body and suspended solids, and most pathogens can leave high nitrogen and phosphorus concentrations. Next, how the wastewater is treated. So wastewater మనము ఎలా ట్రీట్ చేస్తాము? So the composition of wastewater, you have got the information, right? How much amount of water will be suspended, you have seen. Why though why though the composition added to the industrial wastewaters, why it has been changing? So why it has been changing? Because of this toxic substances. So keep this topic in mind. Contact. Next, how the wastewater is treated. మనం wastewater ని ఎలా ట్రీట్ చేస్తున్నాము? So we have used various methods. The wastewater involves the two major steps. So what are the two major steps here? First one is primary treatment. Second one is a secondary treatment. Advanced or tertiary treatment అనేది it is optional, depends upon the strength of the wastewater. Okay, so in the primary process, gravity settling of solids. So through gravity, without any using any pump or some other things, solids అనేది gravity ద్వారా మనకి కింద సెటిల్ అవుతుంది. That is gravity settling of the solids called primary treatment. Second one is microbial transformation of organs. Microbial transformation of organs, organics and ammonia to reduce what? To reduce BOD. Microbial transformation of organics and ammonia to reduce BOD called as secondary treatment. So secondary treatment ఏం చేస్తున్నాం? Microbial transformation of organics and ammonia to reduce BOD level ని తగ్గించడానికి we are going for this transformation, that is secondary treatment. Next, a typical treatment process. A typical treatment process in a wastewater treatment involves, and the first one is bar racks to remove the large debris. So initially మీకు వాటర్ అంతా ఒక చోటుకు వచ్చింది అనుకోండి, what the first thing will do, major big debris means the చెత్త, సాలిడ్ చెత్త ఏదైతే వాటర్ పై భాగాన ఉందో, వాటర్ అడుగు భాగాన ఉన్నదో, those are we are calling as debris. Though this debris will be removed by using bar rack mechanism that already we have seen in third unit. Next, primary treatment, where type 2 sedimentation for foculated particles. The SOR ranges from 25 to 60, ranges from 1.5 to 2.5 hours. This already we are discussing in the unit 3. So third point involves the use of microorganisms to remove the biological oxygen demand of any solids that pass primary treatment. So primary treatment lo primary treatment lo pass aina water ni we are using for second treatment for what? For removal of BOD by using microorganisms. Oxygen is limited and must be supplied. The most common secondary treatment process, activated sludge process. So this will discuss in the next coming topics. The activated sludge management అనేది separate topic anamata. Next, what is the fourth one? The secondary sedimentation to remove microorganisms from the secondary treatment. Okay, so in the secondary treatment law, the secondary sedimentation is so for removing of this activated sludge process law, secondary sediment is removed by this secondary treatment. Next, fifth one is disinfection to kill pathogens using chlorine. Okay, disinfection to kill pathogen organs in using chlorine material. So ఇది ఎక్కడ చూసాం disinfection? See the figure here. If you see the top figure, see this bottle where you are having disinfectant is pouring in the pipeline once the secondary treatment process is completed. So when the disinfectant like chlorine, so if you are introducing in this pipeline, thereby the pathogens will be killed. Thereby the secondary effluent, see the meaning the secondary effluent means the treated water. So if you see the influent somewhere, you can see here effluent. So here also, so these are all the influents, the primary effluent. So primary effluent is coming from the primary treatment, secondary effluent is going to the third stage. I said earlier, influent means untreated wastewater, effluent means treated wastewater. So ఇక్కడ ఏం జరుగుతుంది, see the yellow color liquid disinfectant like chlorine is discharged into the secondary process, thereby some of the pathogens can be killed at the last stage of the secondary treatment, and the next stage is third tertiary treatment. So like this, the wastewater is treated. This is also one type of question, so that you can keep in mind. Okay, so 96 35 35 35 35. Six. So in this methods of treatment also, we can write another way, that is conventional treatment process. Conventional treatment process where we are using normal technology. Advanced treatment process, we are using high end of technology. So in the conventional treatment process, we can use we can write preliminary treatment, primary treatment, and a secondary treatment. So if you want to classify the how the wastewater is treated annappudu, conventional, advanced. In the conventional, primary, preliminary, and secondary. Advanced, you are having tertiary treatment. So like this we can also distinguish, right? Next. So in this secondary treatment process, decay or decomposition of sewage. So we can call decay or decomposition. So biodegradable organic matter which is decomposed by bacteria under the biological condition. So what is biological oxygen matter? So the organic matter which is decomposed by the bacteria microorganism under the biological action is nothing but biodegradable organic matter. Then what's the biological decomposition? So in this secondary treatment process, we are having two types of biological decomposition. One is aerobic decomposition process and anaerobic decomposition process. Aerobic decomposition and anaerobic decomposition process. So aerobic oxidation. Anaerobic means putrefaction process or in absence of oxidation. So we'll discuss these things in this secondary treatment. So if you see the decomposition of sewage, so what I said is aerobic bacteria and anaerobic bacteria. Okay. So the various cycles in this aerobic and anaerobic is nitrogen cycle, carbon cycle, sulfur cycle, calcium cycle, and phosphorus cycle. So the characteristics of sewage is already discussed in the unit 3. So we will discuss these things in detail in the next coming class. Okay. Right. And also we'll see how the microorganisms used in wastewater treatment, and what are the how the microorganisms are used in wastewater treatment, and what are the basic considerations of the wastewater microbiology. So we'll discuss some of the scientific things some of the science basic fundamentals of the science what we have already discussed, and you know well about in the school days, that is the science microbiology. So what happens when the reaction takes place? Okay, see the reactions here. Aerobic decomposition lo em jarugutundi, anaerobic decomposition lo what happens. We'll discuss these things in the next coming class. Okay, so thanks for listening to the class. Have a nice day. So once this video is uploaded in my channel, the link is forwarded to you so that you can read whenever you find the time, and also forward this link to the other students, those who are not coming regularly to the class. Okay, have a nice day.